Okay, so today what we're going to talk about is the sine function. And the sine function, when you write it, is going to look like this. Y equals sine theta. The other thing that you will see is people, instead of using theta, will use x. Y equals sine x. It's the same thing, but I like using theta because when we're looking at our unit circle, we have x's and y's on our unit circle as the points on our unit circle, and I don't want you to confuse x with what we would then have being the sine of x, two different things. So we're going to use y equals sine theta. So theta is going to be our variable, but we're still going to use y. So this all comes from your unit circle. And what we're going to do on the unit circle, would you agree that we go from, in radians, from 0 all the way around in angle measures until we get back here and we're at 2 pi. We're going to graph from 0 to 2 pi in terms of radians, which would be from 0 to 360 degrees. So on our x-axis, or actually now it's our theta axis, okay, we're going to have, here's 0. This is 90 degrees, which is pi over 2. This is 180 degrees, which is pi. 270 degrees, which is 3 pi over 2. And lastly, 360 degrees, which is 2 pi. Whenever you're graphing sine curves, this is what you're going to put down. Pi over 2, pi, 3 pi over 2, and 2 pi. All right? All equidistant because they're all the same distance apart. Okay? Now, here's what we're going to do. We are going to go to different angle measures, and we are going to enter our sine values. And do you remember that your sine value at a particular angle is your x value, right? Or I'm sorry, your y value, right? Watch me mess that up right from the get-go. Okay, so at 0, what is your y value? 0. This is your x, this is your y. So your y value is 0. So at an angle measure of 0, your y value is going to be 0. Okay? At an angle measure of pi over 2, what is your y value? 1. So at pi over 2, your y value is 1. Okay? If you go over here to an angle measure of pi, what is your y value? 0. So that's right here. If you go to 3 pi over 2, what's your y value? Here's -1. And if you go back to 2 pi, what's your y value? 0. And do you see how we could keep going around? And it would keep going this way off to the right. We could do this. This is what makes us a periodic function. Now, we can even do this for values in the middle. For example, I would say maybe right about here, we could write in pi over 4. And what is your y value at pi over 4? 32. Okay, so let's go ahead and we're going to put that in our calculator. So square root of 2, and then we're going to divide that by 2, and we get 0.707, right? So here, 0.707, would you agree, is about this far up if you look over here, right? That's about 0.7 if this is 1. All right, so this creates our sine curve. And all of those y values all the way around your unit circle is where these values come from. All right? And this pattern continues infinitely both to the left and to the right. Okay, there are a couple of things. All right, we'll talk about it all in good time. Let's do a couple of problems where we figure out from our sine curve What is a reasonable estimate for each value from the graph? So check your estimate with the calculator. So first of all, we have the sine of 2. Now, you have a graph here with 2 on it. We happen to know that pi is 3.14, right? So 3 is going to be a little bit in front of it, and then you can section this off so that you fit 1 and 2 equidistant in here. So 2 is about here, and if you go up, whoops, I'll use my ruler, thank you very much. Go up to your graph, and then you're going to go across, I don't know, maybe like 0.9? Does that look kind of reasonable? All right, that could be a 0.9. So I'm going to put approximately equal to 0.9. Now, let's put this in our calculator and see if we can find out. So in your calculator, let's first go to mode, which is right here, mode. And do you see if you go down about 4, you can be in radian measure or degrees? You want to be in radians, okay? Because we're talking 2 radians here, not 2 degrees, because there's no degrees symbol. This is radians. So I'm in radians. So now I'm going to quit that screen and get out of there. And I am going to do sine of 2. Now let's see what I get. Oh, 0.909. All right, so I was really super close. All right, so the next thing I'm going to do is I'm looking for sine of pi. Now when I go over here to pi, what is my sine value? 0. Sine of pi is 0. So let's go back to our calculator and let's try that. So I'm going to put sine, and then right here is my pi key. I'm going to have to use my second to get that, and I get 0. So sine of pi is 0. All right? Now, let's go down a little bit to the bottom of the page. There we go. And we're finding the period of a sine curve. Now, the period has to do with how many cycles of the graph occur between 0 and 2 pi. For example, this is a graph of y equals sine of 4x, which could be 4 theta, on our graphing calculator right here. All right, and you can see that this is graphed from here, from 0 to 2 pi. So this is 0 right here. This right over here is 2 pi. And let's count how many cycles of the graph. So if I start here and I go up, come down, and get back here, that's 1 cycle, right? Go up, come down, and I'm back. That's a 2nd cycle. Go up, come down, come back. That's a 3rd cycle. Go up, come down, and I'm back. That's a 4th cycle. So what this number right here is telling me is how many cycles, how many times the pattern repeats between 0 and 2 pi. So how many cycles occur in the graph at the right? 4 cycles. From pi, or from 0 to 2 pi. 4 cycles. So when we're asked the period is the length of a cycle. Okay, and we actually have a formula for our period. So 2 pi divided by this number 4 right here. Simplify that and you get pi over 2. So 1 cycle is pi over 2 long. Okay, so it's the length of a cycle, and in this case it's going to equal pi over 2.
Wait, the equation's 2 pi over, like, the amount of cycles?
Yep.
Okay. So
It's over this number right here.
Okay, so it's always going to be 2 pi though on the top.
Yep.
Okay.
Yep. And in fact, if you go to the next page, this is written out for you in the middle of the page. It says, suppose y equals a sine b theta, okay? Where a is not equal to 0, and b is greater than 0, and theta is in radians. This is just all normal stuff. Then 2 pi over b, the number right there, is the period of the function. All right, so there's your formula for that. Look right above it. B is the number of cycles in the interval from 0 to 2 pi. So that's important. We haven't talked about the top one yet, so we're going to go to the top of the page here, and we're going to talk about what we call amplitude. So amplitude is another quality of a sine curve. So the graphing calculator screens at the right show 4 graphs of y equals a sine of x. Each x-axis shows values from 0 to 2 pi. So here's what I want to show you. If we go back to this, our most basic sine function, I want to show you something. Do you see how this curve goes back and forth between 1 and -1 with 0 in the middle? Okay? This curve has an amplitude equal to 1 because it's going from the middle up 1 and the middle down 1. So it has an amplitude of 1. Just so we can be clear, the period equals 2 pi. All right? That's the length for one complete cycle. All right, so let's go back to the page we were just on, and we're going to look at these particular graphs. So this guy here is y equals 2 sine theta, whereas this one is y equals sine theta, our most basic one. And what you can see is that that 2 right there means that it goes up higher and down lower, right? What it's doing is changing the amplitude. So the amplitude here, since it's going up to 2 and down to -2, the amplitude here is 2. Yes. So right here, amplitude equals 2. Whereas here, we have amplitude equals 1. Now, let's talk about what happens if that a value is negative. So here is y equals negative sine x and y equals -2 sine x. What's different from when that a value is positive to when that a value is negative? It's flipped upside down, and you already know that, don't you? You know that about all your other function families. When that function starts with a negative value, it flips it upside down, doesn't it? Remember that from all of our translations? That's what's happening here. This is reflected on the x-axis, or the theta axis, if you choose. Now, we would still say that the amplitude here, we wouldn't say the amplitude is a -1. The amplitude equals 1. Because from the middle, it's going up 1 and down 1. And the amplitude here equals 2. Because from the middle, it's going up 2 and it's going down 2. So it says, what is the amplitude of each sine curve? We showed that above. How does the value of A affect the amplitude? And I will tell you, the absolute value of A, so the positive value of A, equals the amplitude. All right? So if we go down here to this next question, how does a negative value of A affect the position of the curve? It reflects on the x-axis, which we recognize as flipping it upside down. So now, if we go back to this box that was further down on the page here, the first bullet point, the absolute value of A is the amplitude of the function. So guess what? Now that you know a basic sine curve, we can actually draw different sine curves from their equation, because here's something we know about sine curves. Here's what we know. They always start right here at the origin, then they go up to 1, back to the origin, down to -1, back to 0, and this repeats. All right? So if we need to change the period or we need to change the amplitude, we can do that without needing to calculate new points. So what we're going to do is flip to page 12, and we're going to do an example. And I tried to find some graph paper that would be helpful for doing this. We'll kind of see how it works. So what I want to do here, I'm going to make this pi over 2. I'm going to make this pi, 3 pi over 2, and 2 pi. So I'm just going to write that in there. And you can see I have 1 and 2 and -1 and -2 already drawn here. It says, what is the graph of one cycle of a sine curve with amplitude 2 and period 4 pi? Oh, well, this isn't going to work. Scratch that out. I need to get all the way to 4 pi. All right, so this is going to be pi over 2. This will be pi, 3 pi over 2, 2 pi. Keep going on up from there. This would be 3 pi. Over here, this is 4 pi. So I guess 2 squares is pi, and 1 square is a half a pi. So we've got that going on. Okay, what is the graph? Using the form y equals a sine b theta, what is an equation for the sine curve? So from beginning to end, it's going to start here. It's going to end here. Where's the middle of this? Right here. All right? So in between the 2 points where it's 0 in the middle, since it has an amplitude of 2, it's going to go all the way up to here. Between these two, with its amplitude of 2, it's going to go all the way down to here.
Wait, how do you know that again?
Because it says amplitude of 2.
Oh, well.
Yep. So it's going to look like this. All right? Now, this is actually interesting, because what if we wanted to write an equation for this particular function? So hang on a sec. Let's just do it. It isn't part of the problem, but let's do it anyways. Would you agree, what is A?
2.
A is 2. Now, here's what we know. We need to know what B is. We need to know what B is. Here's what we do know. 2 pi over B is the period, and that equals 4 pi, right? Because the period is 4 pi. We need to know what B is. Okay? So I need to get B up on top, so multiply both sides by B. And I get 2 pi equals 4 pi B. Divide both sides by 4 pi. And here's what I get. What do you think this is right here?
2. Wait, what?
1/2, right? Yeah. So this canceled, and we get B equals 1/2. So there's our A and there's our B. So if we want to write our function, this is going to be y equals 2 sine 1/2 theta. That's a great exercise to go through. This is so cool. All right, let's go to the bottom question here. It says graphing from a function rule. So what is the graph of one cycle of this? So first of all, what is our amplitude?
1/2.
Yes. So this is going to be pretty flat. What is B?
2. Wait.
Yep. Okay, so we need to know the period, right? So the period equals 2 pi over B, which is 2 pi over 2, which is pi, right? So our period is pi. All right, so I'm going to spread this out a little bit so we got some room to work. I'm going to make this pi over 2 and pi, 3 pi over 2 and 2 pi, okay? But now this thing has to start here and end here, and we know that because that's a period. And we know that in between these 2 points, it's got to go up, come back down, and then come back to here. So would it make sense? It's going to cross 0 right in the middle of that, right? So right here. In between these 2 points, it's going to hit an amplitude of 1/2, which is right there. In between these 2 points, it's going to hit an amplitude of 1/2, so down here at -1/2, right there. And we just drew a sine curve from an equation with only knowing the amplitude and the B value, which gave us the period.
Wait, I don't know why I'm confused about this. So, is it always going to be pi over 2 and then pi